Hi everybody, this tutorial is for help with Assessment 4.05, Conservation of Thermal Energy. What I'd like you to do is go to the announcement page and go over to the Semester 2 help site. Once you're there, go to Assessment Templates. And what you'll find is a new version to the 405 assignment. I'm finding it to be quite challenging for many students, so I wanted to walk you through the process with this video and the help of this file. So go ahead and click on that. And once that's open, go ahead and click download. That will allow you to have a copy that you can continue to work on. So I'm going to use my slides in the live lesson room here to show you what you need to do. But as you're watching this, go ahead and have your file open in another window so that you can work on the assignment as you watch the video. Okay, so first of all, the purpose of this lab is to figure out the specific heat of a mystery metal. So you can see the little piece of mystery metal sitting in this container of water. We're going to do an experiment where we should be able to calculate the specific heat, and that will allow us to figure out what that mystery metal really is. So the first thing we're going to do is measure the mass of the metal and make sure the metal is heated. So in this experiment, it's heated to 170 degrees Celsius. We also have a container of water with a specific mass and temperature, which is cooler, which is what we want. So this data needs to be included in this data table. You're simply going to transfer that information over so you have those variables for later. Now, once we actually put this piece of metal in the water, if you think about something hot sitting in something that's cooler, there's going to be an exchange of energy. That hotter material is going to share that energy and release it to the cooler material around it. So quite easily, I think it's pretty typical to expect the metal to cool off and the water to warm up. Now eventually, if we leave this sitting long enough, they should all be the same temperature, and that's what we have over here, the equilibrium temperature. We're going to call that T final, or TF, and that would be recorded there. So basically, we're just starting with some data in step 1. Make sure you fill in every box. And then in step 2, we're going to figure out how much change has happened for both the water and the metal. So I do want to review this delta equation first. Delta is the Greek letter, which is in the shape of a triangle. So anytime you see that triangle symbol, it stands for delta, and then in this case, delta T, which means change in temperature. And the way we find that is by taking the final temperature minus the initial temperature. So if you think of maybe watching the weather in the morning, and the weather person says the low today is 60 degrees and the high is 80 degrees. The delta T for that day would be 80 minus 60, or 20 degrees. So it's just a simple subtraction that we're doing here. You'll need to do that for the metal and for the water. So be very careful that you're using the right numbers from the blue and pink parts of the table. Okay, once we have that done, if you want to maybe pause the video to go ahead and do those calculations, you can pick up then with step number 3 next. So for step 3, we're going to use the heat equation. And I'm just going to make sure we have each of these variables defined. Q stands for quantity of heat. M, quite easily, is the mass of the material. C is the specific heat, and delta T we've already talked about, the change in temperature. So when we're looking at figuring out how much energy is involved, we can easily find out how much heat was gained if we know the mass of the material, the specific heat of the material, and how much temperature change occurred, which is actually what we have for the water. So I'm going to start with the equation. Q equals mc delta T, and I really should have everything on the left side of the equation. The mass of the water, is in your table from the simulation here. The specific heat of water is right here, given as 4.18, and the delta T for the water you just calculated, which is over here. So once you have all your numbers in order, it really is just a matter of multiplying those three values together to find out how much heat did the water gain. So I would like to see your work here when you're working on this in your file. Show the substitution, show the algebra, and then show what your final answer is with the correct units. That value tells us how much heat the water gained. So that number will be inserted here. Now the next thing we're going to do is move on to step 4. So if you aren't quite ready yet, go ahead and pause the recording. And then we'll now pick up with step 4. So step 4 is a very basic relationship. It's saying that any heat that was gained by a material, in our case the water, must be equal to any heat that was lost by that hotter material. So there's that exchange from one to the other, which means we really don't have any math to do here. I can say that the heat that was gained by the water has to be equal to the heat that was released by the metal or lost by the metal. So the numbers in both of these columns will be the same. Now that I know that, I can move on to step 5. So go ahead and fill in your table for step 4. Pause if you need to. And now we'll move on to step 5. So the confusing part with step 5 is we're going to use the equation, the same one we used in step 3. The catch is that this time we're specifically talking about the metal. Any numbers we substitute in have to be numbers about the metal, whereas when we did step 3, it was all data regarding the water. So if it helps, sometimes what's done is notations are put under the variable, so we don't forget the heat of the metal, the mass of the metal, the specific heat of the metal, and the change in temperature for the metal. And then it's just a matter of finding all those numbers and looking for what we're missing. Now the idea here, as you can see listed in step 5, is to find the specific heat. We don't know what this metal is, so that also means that we don't know the specific heat. So I'm going to highlight that as the variable you should be solving for. What we do know are the others. We know the heat that was lost by the metal. We decided that in step 4. We know the mass of the metal. That's back in step 1. And we also know the change in temperature for the metal. That's over in step 2. So once you gather all of that data and substitute it in, you really should be solving for C. Show that algebra here, and then your final answer of what C is equal to, along with the appropriate units. Now, as a final step, we're going to identify our mystery metal. And the way we do that is to look at this little chart that includes some various metals and their specific heats. Your answer from step 5 should match one of these, and that will be how you identify your mystery metal. Once you've completed that step, you are finished with the experiment and you can save your file and submit for 4.05. If you find that you don't get one of these mystery metal specific heat values, that may be an indication that there is an error somewhere, and please reach out to your teacher and we'll be happy to help. I hope this video was helpful, and please reach out if you do have questions. Have a great day.